Okay. Hello, everyone. Thank you for joining this session. So this is going to be a combined presentation with myself and Kazaya Knopp. In this, we're going to be talking about DB2 for zOS and REST services, and then touch on a little bit of zOS Connect. And we'll kind of just, Kazaya will start speaking, and then I'll take over. But so my name is Tori Felt, and I am a DB2 for zOS specialist out of the Washington System Center. And Kasai, I will let you introduce yourself as well.
Thank you. My name is Kazai Knopp. I'm also a DB2 for zOS specialist out of IBM's Washington System Center.
Great. So yeah, this is session 6L. And if anyone has questions throughout the presentation, definitely feel free to put them in the chat and we're happy to answer those. And I think that covers it. So Kasai, I will let you kick us off.
Great. Thank you, Tori. And I'm going to go off video so you don't see me looking at my second monitor. Okay, so this is, as Tori mentioned, DB2 for zOS and REST services. There we go. So this presentation is actually part of a larger workshop that we do. So if you get to the end of this and you want to know more and you want hands-on experience, please send us a note, send us an email, and let us know, and we would be thrilled to schedule the full workshop with you. So today we're just going to be giving you kind of a shortened version of the presentation. This is the general agenda, and we're going to go through basically all of these, but again, the workshop fully covers this in a little bit more detail. So we will start by talking about mobile trends in the API economy. So this is about DB2 REST and REST services, but mobile trends are what we use on a regular basis, what we see in our day-to-day life, what the overall use of web and mobile applications is. And that is what's being run on REST services and REST APIs behind the scenes. So we're going to move into an overview of RESTful APIs after that, and then specifically focusing on DB2 for zOS and REST. So this is going to be DB2 for zOS REST services. This is native REST services on DB2. If you're a DB2 person and you've used native REST services before, great. Hopefully that will look familiar to you. And if you haven't, we'll walk you through it. We'll touch on creating, discovering, and invoking DB2 native REST services. So how do you actually use those with DB2? And then a more recent update for DB2 REST services is versioning. So you can have more than one version of a REST service running, and you can choose which one you want to run. What version of that REST service are you going to be using? So we'll walk through an example of an application that uses versioning at that point. And then I will pass it off to Tori, and Tori is going to cover DB2 REST and zOS Connect. So that's going to be where you'll see the fully RESTful APIs. Back again, the zOS Connect. Okay, so before we get started with the technical stuff, let's talk about mobile trends and the API economy. So if you're like me, you probably have your smartphone within arm's reach nearby. And that is something that is so integrated into pretty much the world that we live in today. And accessing the internet, using these web and mobile applications to kind of build out this broader API economy. So we have a note here that it is not a fad and it is kind of around to stay. It's been around for a bit now. So this circle chart kind of highlights 5 mobile trends that we see. 5 trends that we see with the mobile API economy. So again, this is going to be your application. So this is going to be what you are using and experiencing. So I mentioned, I'll start with the top right, that green section, mobile is primary. I know that I have my smartphone within arm's reach pretty much 100% of the time. I will set my alarm when I go to bed, and then I will wake up to that alarm and turn it off, and it is with me throughout my day. So that's something that's pretty significant. For this side, we like to walk through an example of going to an airport, getting on a flight. My phone has my mobile boarding pass on it. So if I am traveling and I'm going to an airport and getting on a getting on a flight and a plane, I will log into my phone on the airline app beforehand. I will get my boarding pass and I'll see where my gate is and what terminal and all of that fun stuff. So that's something that will kind of be with me throughout this. Moving to the bottom right corner, insights from mobile data provide new opportunities. So this is a note about location-based messages. This is something that we see in a number of different scenarios, from using, maps to an application or a web application saying, do you allow your location to be shared, or can this site see your location? Anything like that. I know that for the airline example, when I arrive at the airport or if I have a layover, I get a notification from my Maps app that says, you've arrived at JFK. Do you want to go shopping or eat food or see what's around you? So that's a message that will pop up that is certainly location based and will give me all this mobile data is behind the scenes for where I am and what I might be interested in. I'll move to the next one. Mobile is about transacting. So this is web and mobile transactions. This is buying things online, anything that you purchase using your phone, a web application, in an app. So if I'm buying a flight, I might be on my computer using that airline website and looking at the different flight options for the airline that I prefer, that I might get the most points on, and selecting that. And then that will also show up on my phone application for that airline that I purchased that flight. Maybe I used miles. That's also something that could show up in these mobile applications. And this brings me to the next section. This mobile must create a continuous brand experience. So when I buy a flight online, I expect to see it with all the correct information and my boarding pass and my information on my app, my phone. I want to make sure that it has like my airline rewards points as well. So that should be synced. I have this expectation that there's going to be this like seamless flow between different screens and channels. And then finally, mobile enables the Internet of Things, IoT devices. This is a significantly growing industry that has more recently popped up, and it is this idea of machine-to-machine connections. So I know for me, we have a couple of smart homes in my house. So I would much rather say, hey, Google, turn off the lights, than when I'm in bed and I have to go get up to physically turn off the lights. I don't want to do that. So this might also look like when I'm scanning my boarding pass on one of the new fancy machines I know at Newark Airport. You can now scan your boarding pass to go through TSA instead of handing your ID to a real person. You can just scan it. So that will be, my phone is connecting to the scanner that's reading my information that says, hey, I do have a flight coming up. I can go through TSA now. So here, hybrid cloud with IBM Z. This whole idea and experience is for us to be using these web and mobile applications connected to the mainframe. That's why we're here. We all work on Z in some capacity, right? And we have this hybrid cloud environment, and that is something that IBM is really strongly offering, where you can have different types of cloud environments. You can have on-prem, you can have off-prem. They all kind of flow together here. So this chart kind of highlights 4 different areas with hybrid cloud on IBM Z. But today we're actually only going to focus on the top one, this idea of business acceleration, of connecting to cloud applications using APIs, and then making IBM Z data available to the rest of hybrid cloud. As Tori and I are DB2 specialists, we work a lot with DB2 data. That is IBM Z data, and that is what we are making available to hybrid cloud here. And the rest of these are also really great information, but you'll have to go to another presentation for more information on developer productivity and infrastructure cost efficiency and things like that. So I've mentioned API economy a few times now. The API economy is the use of business APIs to positively affect the company. So this is going to be APIs that are around achieving business goals, whether that is extending your customer reach, increasing revenue, creating a new product, or smoothing out a product that already exists, updating it. And a lot of times this API economy is using APIs between companies. Open API, that is very common. A lot of APIs are publicly available and they can often be developed by a third party. So one example is Google Maps. The Google Maps API is something that can be used. It's publicly available and can be used in other applications. So if I call a car using Uber, and it has that map ability of where I can see I've called the car, it's arriving to my house. That map function is based off of the Google Maps API. And so that is something that you can assess and charge for and rate and all of that, depending on what your model is for managing APIs. So this is how business APIs can kind of affect the overall API economy. What APIs are being used by what companies, how much, to what extent, all of that. So bringing this back to the cloud and the mainframe, we have this expectation of cloud environments, of hybrid cloud, of anything like that, that they're super easy to use and you can kind of connect to them whenever you want. You can test things out, you can try things out without any penalty from that. You're not tied to a single solution. You can have this hybrid cloud environment that's perfect and seamless and nothing ever goes wrong. Everything is familiar and standardized. That's what we expect. Is that what happens? I don't know. But we also have a Z behind the scenes that is part of this hybrid cloud environment that we're talking about. And I know for even in my experience, something that Tori and I see is that a lot of people come with this misconceptions, myths of zOS. Things like it doesn't support modern technologies, and really take a long time to make changes. There are security policies, but they might seem strange or foreign or hard to use, or that Z doesn't integrate. And these are all misconceptions. So we are here to say that Z is modern and is easy to use and does use a lot of these technologies that are available in other areas as well, in other areas of hybrid cloud. So the reality is that Z uses, you know, this first one here is VS Code. There's a Db2 for zOS developer extension highlighted right there in a VS Code, kind of across the board for other people that I know that are in development and programming, use VS Code as their primary user interface. And we have an extension for Db2 for zOS there. One thing that we'll be talking about today is Swagger. That's the documentation setup that's often used with REST API, specifically IBM Explorer. That's the Eclipse-based user interface that we use in the lab for this workshop. And then the set of languages at the top, you can use Python and Java and Go and Swift. Those are all available in Z as well. You can use IBM API Connect, and this use of APIs is kind of highlighted here as well. And that's what we're going to be talking about today. So this brings me to APIs. So there's a report that's put out. This is the 5th year that they've done it. It's called the State of the API. It's done by Postman, which is a company that we actually use also in the workshop, where you can kind of manage REST APIs through their interface. And this company did a report polling, I want to say, over 5,000 developers. Yep. Ranging from, and also including CEOs, customer success managers, full stack developers, small startups, large corporations, across industries, financial services, technology, healthcare, other sectors. So what they were looking at is their use of APIs and their interest in them. So these stats kind of highlight some areas here that are relevant to what we're talking about today. So this first one, 92% of organizations that were surveyed plan to invest either the same or more resources into APIs in 2024. So that means that APIs are, either here to stay or increasing in terms of resources that are being put towards APIs. 65% of the businesses surveyed, 65% of business APIs that were included generate revenue. So that's about 2/3. And one thing that was noted as a difference here is that a lot of small startups, their business APIs didn't necessarily generate revenue, but as the companies that were surveyed got larger, more of their business APIs generated revenue. So that's something that we did see trend upward with size and length of time of the company, I should say. Something that's not necessarily a startup would have more business APIs that generate revenue. And then 60% of respondents use Gen AI tools for coding. So that is something that is new and big, and I'm sure that you've heard of generative AI in some capacity here, and a lot of developers are using generative AI tools for coding, whether that's code generation or documentation or anything like that, skills learning. So on continuing notes on the API economy, a few emerging trends also popped up. This was in a report called Insights into the API Economy. And this first one here is kind of where I left off from the last slide on Gen AI. So AI and machine learning has provided a lot of helpful availabilities to coders and programmers and developers. I'd really be curious actually if you have any experience using Gen AI right now. Yeah, feel free to drop anything in the chat, even if it's not a question and you just want to share your experience about using APIs or AI. I know that this is a lot with, more, depending on what languages you use, certain languages are more likely to have Gen AI that's available for them. This is identifying mistakes, producing code, documentation, teaching skills, things like that. Another trend that was discovered or found or observed was this API first approach, where APIs are expected to be the first preference for organizations on the note of communication. So if you have a company and you're trying to communicate with another company, sending and receiving information, gathering data, updating data, APIs are kind of expected as the protocol and the format. Hybrid API architecture. This is where we see this hybrid multi-cloud system setup. This is what people are using with the API economy, because APIs are super flexible, so they can move across this hybrid API structure. And then finally, security. That is always a burning hot topic, where security is paramount to protecting sensitive data that is covered when APIs are being used, making sure that API interactions are safe, whether that's using encryption or authorization or tokenization, detecting threats, anything like that. So this is all part of what we're looking at with the API economy overall. So let's jump into an overview of RESTful APIs. We've been talking a lot about API economy. So I kind of want to define REST first. REST stands for Representational State Transfer Architecture. It is an architecture, it is a protocol for sending and receiving information. How do you send and receive data? Let's have it in the standardized format. It is stateless, meaning that you just send the information as is. You do not need to keep track of what the state of the system was before or after this information is sent or received. It uses client-server relationships. So that means that when you're sending and receiving information, one side will be a client and one side will be a server. So the client can receive information from the server. This is pretty fluid and can change, but that is generally the setup for REST. It also uses a cacheable communications protocol. It uses HTTP. That stands for Hypertext Transfer Protocol, but you probably recognize that as what's at the beginning of your web addresses or your URLs whenever you're accessing the internet and you have a web address or whatever website you're going to. It'll start with http://www, etc. So that protocol is what is used for REST APIs. It's also used for the World Wide Web. A RESTful API, so API is an application programming interface, an interface that is used to program applications. We started by talking about web and mobile applications. So this API is this interface that's used to program it. It uses HTTP requests. So this is get, put, post, delete, anything like that. So that's what we're going to be talking about in this presentation today. So some key principles of REST are that it uses HTTP verbs, create, read, update, and delete, CRUD operations. If you're in development, you probably recognize that. Those are associated with get, post, put, and delete. So you will pair one of these methods with a URI, a uniform resource identifier, basically the same thing as URL, slightly different, depending on what you qualify that as. And the URI specifies where are we going? We want to get information from a particular location. We're going to specify the host and the port and where it is exactly in that location for the information that we want to do something with. So in this example, we used get, we used that method with, that would be read, with this particular URI, acme.com. We're looking at customer number 12345, and we want to get their personal details. So then we will send that across, and then the data that we're looking for will be returned to us. So that's this response and body that's listed here. So REST and JSON. This is going to be the interface, the REST and data payload format, JSON. REST, straight transfer, this particular format. So that's what the application will read and then understand what are you looking for? What do you want to do here? And then JSON is going to be this JavaScript object notation. That is what the data is returned in. So this is this name value pair format that we're seeing here. So we are looking at account number 12345. In this example, we're depositing $1,000 into Smith's account. So we'll be updating that account. So some HTTP request method examples using the URL specified at the top here, myhost.com/customer235. So that's the URL, URI, either one. If we call get with that URL, that means we are looking at that record. I'll bring that in a minute. We're looking at that record for customer 235. Put, that method is going to be associated with information because we're going to be updating the record when it's paired with this URL. So in the last slide, we updated Smith's account. So we'd be putting in $1,000, putting in $1,000 to that account, to, in this example, customer 235. Post, that is equivalent to create. This will also require some information. And that means that we are creating a new record when paired with this URL for customer 235. Delete, pretty self-explanatory. We're deleting that customer. That's been specified. So these are often associated with SQL terms. This is DB2 that we're talking about here. So we're looking at a database. We're using SQL, structured query language, SQL, whichever one you refer to it as. So get is going to be associated with select. We're selecting that customer. Put, update, those are kind of pretty equivalent. Post, the same as insert, and then delete, again, delete. So this is kind of what you would see in SQL terms that's associated with these here. And I bring this up because DB2 native REST only supports the post method for applications. So out of those that we just talked about, get, put, post, and delete. DB2 native REST, so what you're using in DB2 only supports the post method for applications. Git can be used in some instances for system-related functions, but not for applications. And this is why we're going to be talking about zOS Connect later, is because zOS Connect allows for a fully RESTful API. And that means that you can use git, put, post, and delete, and not just post. So with DB2, you can pair this post method with those SQL terms. So if you wanted to delete customer number 235 using DB2 native REST, it would actually post with the URL a SQL delete to delete that record. So that's kind of how DB2 native REST navigates using REST APIs. So why is REST so popular? Oh, okay, we got a question in the chat. Why does DB2 native REST only support the post method? Um, that is a great question. Thank you for your question. My understanding, having not been in DB2 development for this, is that post is kind of the one that takes the least amount of overhead. It's relatively easy. It kind of covers all the boards. It's create, it's insert. So you can kind of pair that with something else to accomplish what you need to in terms of communication. Implementing all of those is just something that was not fully done in DB2. So that's why we have zOS Connect, because it kind of pulls all of the rest of the HTTP abilities in, where DB2 started off with post, and that was enough to kind of get around with it. So I think that it just is a lot more. If there's somebody here that has more insight into that question, please feel free to post in the chat. I recognize that I'm not the person who worked on this, so that's my tentative answer, I would say. So why is REST so popular? It is built on an ubiquitous foundation. It's built on HTTP. That is what is used on the World Wide Web. That is pretty much what is used across the board when it is anything to do with web applications, web browsers, mobile applications, anything like that. It is also increasingly common. As we were seeing in the statistics from that State of the API report, companies are only using APIs more. Maybe the same, but if not the same, then more. So that's pretty significant. It's a lot easier to communicate with another company if you know that they're also going to be using REST services. It's also relatively lightweight. It uses this like stateless protocol that's also mentioned here. It's a lot less overhead than SOAP or WSDL, which are some older protocols that were used before REST was really out. It's also relatively easy for development. REST also uses JSON. That's the most common data payload format with these name value pair formats. It's pretty easy to read and understand regardless of kind of what background you have. So moving into DB2 for zOS with REST services, there's 4 objectives that I kind of want to highlight here for why DB2 has REST to begin with, even if it is just the post method. You can use REST and JSON to invoke a SQL statement or a stored procedure. And ultimately, this allows for new business value for your enterprise data. You know, one of those, that hybrid cloud, that first slide where we had those 4 points, this is allowing your DB2 data to be available in this like REST hybrid cloud mobile application environment. And you're also modernizing using the power of SQL. So that's what we're using with DB2, and that's also what you can be using with REST services and REST APIs. And finally, you're fully unleashing DB2 data for the API economy. That was that main thing that we talked about, is being able to use APIs and using DB2 data with that. So how do we actually use a DB2 REST service? DB2 REST service will be invoked using direct DB2 DDF REST access, the distributed data facility. That access is going to be what REST services can be invoked through. And a service consists of a SQL statement or a stored procedure call. So there's in a service, you're going to have one SQL statement or one stored procedure call per service, where a service is a statically bound package in DB2. So they're just read in DB2 as a normal statically bound package. And it can use call, delete, insert, truncate, select, update with, all of those good things. Merge can be used in a stored procedure, but it won't work with a single SQL statement. Don't ask me why on that one. I don't have an answer for you, but that's just a note there as well. All of the various DB2 based SQL data types can also be used with these REST services. So this includes binary large object, character large object, double byte character large object, and XML files. So here's a brief overview diagram of what's going on. So before REST, this might be things like JDBC, Java Database Connectivity, ODBC, Open Database Connectivity, or .NET. Any of those forms can access DB2 through a regular port number. It would go to the distributed data facility, whatever data and information is there would then be parsed using direct relational database architecture, things like that. Now we have REST. We have our mobile application in the cloud, as indicated by those icons, with our JSON data, those name value pair formats, using native REST through the same port number. And now once inside of DB2, we're going to parse it based off of JSON and HTTP. HTTPS is for secure. And once inside of DB2, regardless, you can do everything that you would normally do, like authorization checks, thread creation, SQL execution, etc. So in talking about the flow of using REST services, we have two personas that we're going to talk about in this presentation. First, we have Max, the mobile app developer. And then we have Devin, the database administrator, DBA, or DB2 app developer. I recognize that for some companies, one person might be both of these. You might have a lot of people for each one. But for the case of this presentation, we're going to be talking about them as if they're two distinct personas. So Max, our mobile app developer, is going to be the person who has the authority to invoke a DB2 REST service, again, consisting of a stored procedure or SQL statement. The output is going to be returned in JSON format. So Max does not really need to know SQL, nor the data came from DB2. They're just going to be looking at JSON. Devin, on the other hand, is going to have the authority to create a DB2 REST service or reuse a stored procedure or SQL statement that's used in the REST call. But they don't necessarily need to know JSON. They're the ones that are going to be creating the service. To manage DB2 REST services based off of one of your personas, there's three ways that you can manage DB2 REST services. One is a REST client in a browser. This is typically a plugin to whatever browser you want to use, and then you can manage your REST client there. There's also an application for managing REST. In our workshop, this is Postman. It's a separate application. It's similar to a browser look and feel in terms of navigation, very standard user interface for that. If you prefer standard DB2 interactions, you can use the bind subcommand to manage your DB2 REST services. So this is if you're using TSO, green screen, you can use your bind sub, or you don't even have to do that. You could be using IBM Z Explorer. If you want to use the bind subcommand, that also works. So here's kind of the progression that we see for using DB2 REST services. Not exactly a straight line, but here's the narrative of it. So Max, our mobile app developer, Devin, DBA, DB2 app developer, they will both have the authority to discover services. Look at what already exists, see what's out there. Devin's going to be the one with authority to create the service. Both of them can look at it. Max, as the mobile app developer, is going to be executing it. And then Devin will have the authority to delete it, similar to the create authority. So to kind of dive in, discovering a service. This can be done with the appropriate authority, usually sysadmin or control or DBA, DM. You will issue a post or DB2 native REST with DB2 service discover. So you'll specify the host and the port that's listed here in the middle of the box. Call services DB2 service discover. If you have fully RESTful capabilities, you can just call get on host port services. So whatever location that exists in, you can just get the services. And assuming this all goes well, so you issue your get with /services with a fully RESTful environment or post with DB2 REST, you'll get a return code of 201, assuming everything goes well, because it always does, right? That's your successful completion code. This is an HTTP code, so that's something to note. It's not a DB2 code if you are used to DB2. Creating the service. So this is going to be Devin, if you'll see them in the top right corner. Again, this is going to make sure that you have the correct authority and privileges to create a service. This is going to be privileges used to create a service and bind the package. So to create a service, this one will actually be post because that's the create a new one, and you'll call it with DB2 Service Manager to create a new service, and you'll specify in the HTTP body what you want to do. And again, you'll get your successful completion code of 201 as an HTTP code. Another way to create the service would be using that bind service subcommand that I mentioned as another way to manage the services. So if you're creating the service and you want to do that with the bind subcommand, you'll submit a batch JCL job. So this is a screenshot from IBM Explorer, which is an Eclipse-based user interface. You can also use this in a TSO interface, and this is an example of how you would create a service. This one in particular is using a stored procedure. So you would bind it, and then you would name it, select by department stored procedure in this particular example. I was opening the chat here. We have a question about having the execute authority on a service to be able to discover it goes against the idea of the API economy. That is an interesting discussion. I think I would like to know more about what you mean by the idea of the API economy. Feel free to add more to the chat, and perhaps Tori and I can also talk about that a little bit more. But it does, at least in DB2 for REST services, you do need the correct authority to create the service. And if you're using the bind subcommand, you'll get the DB2 code 4000 when it's successfully completed. Okay, I'm not going to dive into the rest of these for today, but if you would like more information, you can click the hyperlink in these slides, and that will take you to all of the rest of the details. They followed the same format for display, execute, and delete. Troubleshooting. So in the off instance that you don't get the successful completion code of 201, maybe you get something else. Here are some status codes that give you some information based off of what's going on. You can click the link to learn more. So you can have a 200, that's your success. 300 is a redirect. I do want to highlight, so if you get a 400 level error, since this is an HTTP code, it's basically the same as getting a 404 not found. So if you've ever tried to go to a web page that doesn't exist, you get the 404 not found code. That's the same code that's being used in REST services, since that's based on HTTP. And then 500 level would be a server error. There's something going on the server side. Okay, so this brings me to versioning. This is the last section for my section, and then I'm going to pass it off to Tori, last portion for my section. And this is a newer feature for REST services. It was associated with this APAR PI 98649. And versions of REST services allow for the development and deployment of new versions of REST services while existing versions are still being used. So that means that we can create a new version of a REST service on a version that already exists, and then use that for development and deployment, in development and deployment. So it's built on existing package versioning support. You'll use the same authorizations that you would have been using as well. You can specify the version ID. So that's going to be something that's associated with versioning, is that there will be a version ID. The default is V1, then V2, V3. You can name it anything you like, Fred, Velma, Scooby-Doo. And then you can also select the default version. So let's say you've created a REST service, the default is V1, you've updated it, created version 2 of that service, and you like that one better, you can select that to be the default version. So we have our URI format. So that's what we're using with the HTTP REST call. The original would be services collection ID is in brackets because that's optional, and then service name. So we were just looking at, how would you display or create a service, calling services, IBM services display employee. Now let's say you used versioning, you've enabled versioning, that URI changes slightly, the collection ID is no longer optional, you have to include that, but at the end of the URI is where you have your version ID. So that is optional, it will default to what you've specified the default to be. So it could be V1 or whatever you decide to name the version ID. So we're going to walk through an example. We have a mobile application for our company where perhaps we are displaying employees. And so we have this display employee REST service. Christine Haas is an employee, and that's showing up on our mobile app. Now let's say we enable versioning, and then we create a new service, select by employee number or empnum. So we have that listed here. Christine is employee number 10. And now let's say after I've created this service, V1 of select by empnum, I realize it might be helpful to also have Christine's manager listed here. So instead of creating select by empnum with emp manager, I can just do version 2 and include the manager information in version 2 of select by employee number service. Now let's say Christine is doing a really great job and I want to call Christine's manager and say, hey, Christine's been doing a really great job. Maybe I should include the manager phone number in this REST service. Instead of creating now what would be a third REST service, select by employee number with manager and manager's phone number, I can just create version 3. And I've now listed the manager's phone number in my mobile application for selecting by employee number. So Db2 REST service versioning is enabled by applying the APAR and then running the sample job DSN TIJR2. One thing that we do note is that if you've applied the APAR and enabled it, and then you remove the APAR, the entire REST service functionality will be unavailable. I would not have to say this note if this wasn't something that we had come across. So if you have enabled versioning, just leave it. So to wrap up, here are some features of versioning. There is no impact to pre-existing versionless REST services. They kind of remain the same. They will have an empty string value for their version ID. So in the previous versioning example, we had that display employee. That was a service that existed before versioning. That would just get empty string value for version ID. Because after versioning has been enabled, services will always be versioned. So they will always have a V1, V2, whatever is specified. And ultimately, this simplifies the modification of changing these services, ultimately improving your time to market. Okay, I know that we are sort of running out on time, so this is where I will pass it off to Tori.
Okay, thank you. All right, so you may be thinking, well, can't you do JSON and REST already? Because I had talked about how you can use native REST services with DB2. And really, yes, you can do JSON and REST for discovering and using these REST services. But there are some drawbacks with that, and that's why we have zOS Connect. So, for example, we saw that DB2 only supports the post method. So since DB2 native REST only supports the post method, we want our developers and DBAs to be able to use the fully RESTful methods. And that's where zOS Connect comes in. So mobile and cloud programmers are able to use post, get, put, and delete with zOS Connect because zOS Connect is fully RESTful. So for example, if you were using the DB2 post method, you could use the DB2 post method with the SQL statement and the appropriate RESTful method, depending on what you are trying to do with your REST APIs. So zOS Connect is a way to make sure that you're able to use those fully RESTful methods as opposed to just the post, for example, with DB2. Okay, so this is showing the architecture diagram. Kasaya talked about this picture with just native REST, but here we have zOS Connect added in. So this kind of helps understand where zOS Connect fits in. So we have our DDF access before REST. If you're using JDBC, ODBC, or .NET, and you would go through a port number, you would use DRDA parsing, and then with the native REST, you would use HTTPS and JSON parsing. And then going through the diagram, we have our mobile apps, and then we can see that that is supporting the post method only. But then when we add in zOS Connect, this is where the fully RESTful methods come in. So we have our get, put, post, and delete with zOS Connect. So the architecture is the same. zOS Connect is just an added feature here with our mobile applications in order to extend the services and capabilities with your REST services that you create. This page is going to show kind of the difference between a native post SQL statement as well as with zOS Connect. So if we start on the top here with this DB2 REST service, we can see how this might look a little complicated at first. So we're specifying our post method. We are specifying the URL, the port number. We are saying that we want to select by department, and we are specifying department 1 for that specific number. So this is how this method looks with just native REST. But then when you bring in zOS Connect, this is the same exact URI. It's calling and doing the same exact thing. It's just, we can see it's been simplified. So here we are we want to get information from a specific employee from that same department number. But immediately we can see that it's a lot more simple. We're actually using the appropriate method. So as opposed to using the post method, which is kind of funny to specify post if you're wanting to get information, we can actually use the method that works well with this example. So we are specifying get as opposed to post, and it just overall makes it easier and more developer friendly from that developer point of view. And it's going to be producing the same exact output. It's just simplified. Okay, zOS Connect. So it serves as a single point of entry to your zOS assets. So whether you're connecting to DB2 or IMS, MQ, WAS, Kix, whatever you're connecting to, it's going to be a single point of entry. It's a single configuration. So your developer or application just basically has the single point of entry to accessing your Kix or IMS or DB2, and it uses a single security administration. And as I explained, it uses the fully RESTful APIs. And there's no code written to do any of this, so it's built from a developer-friendly point of view. So you don't have to learn any new code when using zOS Connect. And then also a point is that zOS Connect uses mapping. So we'll kind of go over that in a few slides. But this is showing a high-level overview of zOS Connect. So we have these two main ideas here, the runtime server and then the tooling platform. So the runtime server, this is basically where your APIs are hosted. What happens is the server will receive a request. It does security checking and it passes requests to your backend subsystem, so Kix or IMS or DB2, and then it will put that information back out to you. It can run as a started task or as a container image. And then the tooling platform, this is where you're defining your APIs. So it's actually it's like a graphical user-based interface. And that's where you are able to do your data mapping. And basically you can test and create your APIs in this one tooling platform. And then it will create a file from your APIs for you to deploy elsewhere. So that's kind of the overall idea of zOS Connect. You have your runtime server and your tooling platform. Okay, so I mentioned data mapping. And data mapping is a majority of the work that zOS Connect is doing. So what happens is your application will send a request. It goes through this mapping, which is in the zOS Connect address space. And then it is sent out to your subsystem address space. So whether you're using a Kix program or a DB2 REST service, it gathers information from that, brings back the information, does its mapping, and then passes it back to the requester. And this is showing that more in detail. And if we see here, we are going to do an example with getting information from Acme for a specific customer ID. So this is all happening in the zOS Connect address space, this idea of mapping. And for this example, it's actually a Kix program that's being invoked. And we can see here that if we follow the arrows, we start off with our request to get information from acme.com. Then that is paired with the information from our Kix program. That includes that gray box. So we have information on the customer ID, name, address, telephone, and that's getting mapped to this JSON name value pairing. So we can see that we have a response of 200. So that's great. It means it worked. And then again, we have our ID, name, address, and telephone. So it basically used that information from Kix from that program and mapped it to this JSON name value pairs. And then that response will get passed back out and sent to the requester. And this all happens in that tooling that I mentioned. And when this is happening, this mapping, the program that is being called, those applications will not be affected in any way. They remain unchanged. And as I mentioned before, we want zOS Connect to be developer friendly. So this mapping is creating these developer friendly APIs. All right. The next couple slides are some examples of using native REST services in zOS Connect in real life companies. So this first example, this was a large US manufacturer, and their original challenge or pain point was they really wanted a simple portal to navigate DB2 for zOS. So they didn't want they didn't want their developers to have to really be experts in DB2 for zOS and have to, do specific coding to figure out different aspects. So what they did was they actually used the DB2 native REST services, and they created this. It was a web browser. It was a user interface for their developers to basically interact with DB2 for zOS. So this in turn made any developer, DBAs, whether they were new to DB2 for zOS or they were experienced, they could easily navigate DB2 using a interface that was familiar to them, and it wasn't just using the standard DB2 for zOS. So that's just one example. And then there's one more example as well. This was using zOS Connect. So this was a large automotive company. And basically, what happened was during COVID, the pandemic, so this company all of a sudden started getting tons and tons of loan extension requests because customers weren't working. They basically, a lot of people needed extensions on their loan. So before the pandemic, before they implemented the solution that I'll talk about, this process was a manual process because they weren't getting tons and tons of requests on a daily basis. So it was just a manual process and it worked fine for them. However, when COVID happened and they were getting these requests every day, they needed something to kind of digitize that process. So they figured zOS Connect would be the best option for them in this scenario. So they use zOS Connect to take that manual loan extension process and they basically digitized it. So they were able to grant loans to customers a lot more quickly. And overall, that really just made the customer satisfaction go up, and customers were happy because it wasn't taking a super long time as it would have if that was just based on their manual process. So that's just an example of how zOS Connect has been used in order to help companies and promote customer satisfaction. Okay, and that brings me to the end of DB2 for zOS REST services as well as zOS Connect. And again, thank you all so much for joining today's session. I believe there on the next slide, there might be a QR code. Yeah, okay, so yeah, this is session 6L. And hopefully everyone who had questions, I'm seeing a lot in the chat. I'm seeing Keziah answered some. So hopefully everyone had their questions answered. But if not, please feel free to reach out to myself or Keziah and we can discuss offline.
Oh, thank you very much, Tori and Keziah. That was once again another really interesting presentation and great questions, everyone. Thank you very much. Um, I shall leave the doors open for another minute if you'd like to ask another question. But please don't forget to give full marks to Keziah and Tori on the feedback form because hey, we want them back. Thanks both.
Thank you, Marcus.
Great to see you again. I'll leave it open for one more minute. So, any more questions? Okay,
Okay,
it
great.
looks like
I think that I saw some things in the chat. Yeah, thank you.
okay. People are dropping off. So, yeah, once again, both thank you very much, and take care. All the best, and we'll see everybody else again tomorrow.
Okay.
Thank you.
Thank you very much.
Bye.